So P4 starts with looking at the domain of different expressions. Your domain, you're literally giving what x can be equal to or could be equal to or what x cannot be equal to. The easiest way to look at this is looking at the first example. You're given 3 different expressions. The first is just a polynomial with x as like whole number parts. It's not in the denominator of a fraction. It's not under a radical. So whenever you have something like this, where it's x to a power or something times x, it would just be all real numbers. So you're going to write that in interval notation. So you're going from negative infinity to positive infinity, and that's your domain. So that's the reason why it's just from negative infinity to positive infinity, because x is not in the denominator and x is not under the square root. So anytime it's something like this where it's just an expression like 2x cubed plus 3x plus 4, it's just all real numbers. So it's literally asking you, the domain is, what can you plug in for x? What are the possibilities of the numbers that you can plug in for x?
What is it to the left of it?
The D with a colon. It just designates the domain is from negative infinity to positive infinity. For example, B, you have the square root of x minus 2. Anytime you have a square root and x is in the denominator, you're going to take whatever the expression is under anytime x is underneath the square root, you're going to take whatever the expression is underneath that square root that x is involved in and set that expression greater than or equal to 0 and solve it for the variable. So in this case, the part that's underneath the radical is x minus 2. You cannot have a negative number underneath the square root, which is why we set that expression greater than or equal to 0. In order to get x by itself here, we just move that 2 over by adding it to both sides, and that gives you x is greater than or equal to 2. You take that expression because that x is involved in the expression underneath the square root. Okay, remember, when you're taking the square root of anything, we've said in the past couple sections that we've gone over, you cannot take the square root of a negative number. That's why we take that expression, whatever it is, and we set it greater than or equal to 0. It can equal 0 and it can equal any positive number. So that expression has to be given to you, or you have to take it and find what you can plug in for x in order to get a positive number or 0 underneath that square root. From here, though, you got to put it in interval notation. So if we look at this as a number line, if we graphed it on a number line, at 2, you would have a closed circle. And since your x comes first in the inequality, your sign points to the right. Our line's going to run the same way. It's going to run to the right. The interval notation of this, your smallest number is 2. Biggest number is infinity. We said before that the infinity automatically gets the parentheses. The 2 is going to get a bracket, though, because it includes the 2. It's also equal to 2. So anything from 2, including 2, to positive infinity, you could plug in for x and get something that you can actually take the square root of. For example, C, you have x plus 2 over x minus 3. Now, this one is a fraction, and you have an x in the denominator. When you are working with fractions, what number cannot be in the denominator? There can be a negative in the denominator. What number cannot be in the denominator? What makes the fraction undefined? 0. So because 0 can't be in the denominator of a fraction, you're going to take the expression in the denominator, in the bottom of that fraction, and you're going to set it not equal to 0, because whatever's in the denominator can't be 0. So in this case, that x minus 3 gets set not equal to 0, and you solve it for x. We're going to move the 3 over, in this case, add it to both sides, so that x is not equal to 3. Now, this is not interval notation. If we were to graph this, you're not including the 3. So that's every number from negative infinity to positive infinity except 3. So your line does not go over the 3. It goes all the way up to 3, but it doesn't include the 3. So in order to represent that it goes up to the 3, but doesn't include the 3, you put parentheses on where that line breaks. From here, your interval notation can be written. So you're going from negative infinity up to 3, not including the 3. So that 3 is going to get a set of parentheses on it, with a union from 3, not including the 3, so it gets the parentheses, to positive infinity. So again, your interval notation here, you're going from the lowest point up to where that line breaks, which is at 3. You put parentheses on the 3 because it doesn't include the 3. Then you start that line again at 3, but doesn't include the 3, so parentheses on that, all the way to positive infinity. Next part goes over simplifying rational expressions. When you are simplifying these rational expressions, you are also stating what your variable cannot equal in interval notation. So you're going to use the same concept that we just went over, but you're also going to be simplifying fractions. When you're simplifying these rational expressions, you need to make sure that your numerator and your denominator both are completely factored. So you're going to be using factoring in this too. So it's all stuff you previously know. You're just applying it to a new concept. If you look at this fraction that's on this page, you have a times c over b times c. Because c is the same on both the top and the bottom of that fraction, they cancel each other out. Your c is in the denominator, your b is in the denominator. So c can't equal 0 because 0 times anything is 0. So c can't equal 0. At the same time, your b can't equal 0 either. Because again, 0 times anything is 0. If we look at the example that goes with this, for a, you have x squared plus 4x minus 12 over 3x minus 6. In the denominator, you have a variable. So set that 3x minus 6 not equal to 0. Tell me what x can't equal. If we move that 6 over, we're going to add it first. That'll give us 3x is not equal to 6. From there, divide each side by the 3. X cannot equal 2. We said from the questions that we did before this, that if you were to graph this, this would include every number from negative infinity to positive infinity except 2. So that means you're going from negative infinity up to 2, then from 2 to positive infinity. So your domain for this one is just going to be from negative infinity to 2 with a union from 2 to infinity. That's part of your answer. Is that your answer for simplifying this rational expression? No. You just told me what x can and can't equal. That's it. You haven't done anything to simplify that fraction yet. In order to simplify that fraction, you need to factor both your numerator and your denominator. The top, you have a trinomial. You do not have a greatest common factor in it, and you have an a that's 1. So find the factors of your c term that add up to be your b term. Your c term is that negative 12. So your factors of negative 12 that add up to be positive 4 are negative 2 and positive 6. So this trinomial top in your numerator is going to factor to be x minus 2 times x plus 6. In your denominator, you have that 3x minus 6. You have a greatest common factor between these two terms, which is 3. So that factors to be 3 times x minus 2. You look at this fraction. You need the exact same thing on both the top and the bottom of that fraction in order to cancel the 2 out. Is there the same exact thing on both the top and the bottom of this fraction? What? X minus 2. X minus 2 is in a set of parentheses, and it's on both the top and the bottom. So because it's on the both top and bottom, they can cancel each other out. So this just leaves you as x plus 6 over 3. You cannot simplify anything else with that. That 6 that's on the top is attached to the x with addition. So you cannot do anything even though there's a 6 on the top and a 3 on the bottom. It does not matter. That x and that 6 are literally attached to one another as one. So the simplified version of this fraction is the x plus 6 over 3. Your domain is from negative infinity to 2 with a union from 2 to positive infinity. For example B, we're given 3x squared minus x minus 2 all over 2x squared minus 8. You have an x in the denominator, so first thing you got to do, tell me what your domain is. We're going to take, bless you, we're going to take the 2x squared minus 8 and set it not equal to 0. For the 8, we add it to both sides. That gives us 2x squared is not equal to 8. From here, divide each side by the 2. Get the x squared by itself. That's x squared cannot equal 4. In order to get x, instead of x squared, what do we do on both sides of this equation? If you take the square root of both sides in an equation, what do you have to include in your answer? Plus or minus. So x cannot equal plus or minus 2. This means that you can't have negative 2 as x. You can't have positive 2 for x. So that's two different numbers here. So on your number line, you're going to work with negative 2. You're going to work with positive 2. Your line is going to go from negative infinity to positive infinity, but it is not going to include negative 2 or positive 2. So you have two breaks in this line now. You still use the parentheses in order to designate that it goes from negative infinity up to negative 2. Then it goes from negative 2 to positive 2. Then it goes from positive 2 to positive infinity. For the interval notation of this, you're going to have 3 parts in this union since you have 3 parts of that line now. So you're going from negative infinity to negative 2 with a union from negative 2 to positive 2 with a union from positive 2 to positive infinity. So it's covering every number from negative infinity to positive infinity except negative 2 and positive 2. Oh, didn't want to do that. There we go. So from here, you got to go back to that fraction and work on simplifying that fraction. Your numerator, you have a trinomial that does not have a greatest common factor and has an a that's something other than 1. So remember when you tested on this the other day, when you're factoring a trinomial where a is not 1, you multiply your a and your c terms. You find the factor of that product that equal your b term. You replace your b term with those two factors, and then you factor it by grouping in order to factor it fully. So in this case, the 3 times negative 2 gives us negative 6. Your factors of negative 6 that add up to be negative 1 are 2 and negative 3. So this gets rewritten as 3x squared. You can do minus 3x plus 2x minus 2. And then you can factor this by grouping. Factor out a 3x from the first set, factor out a positive 2 from the second. That gives you 3x times x minus 1 plus 2 times x minus 1. Two parentheses are the same. So your numerator is x minus 1 times 3x plus 2. Now your denominator is that 2x squared minus 8. You have to factor a greatest common factor out first before you do anything else. If you factor that greatest common factor out first, they're both divisible by 2, so that's going to give you 2 times x squared minus 4. X squared minus 4 is a binomial. You have subtraction between the two terms, and you can take the square root of both terms, so that's a difference of squares. So that factors to be 2 times x minus 2 times x plus 2. So in your denominator, you just have the 2 times x minus 2 times x plus 2. Now look at your fraction. You have an x minus 1 on the top. Is there an x minus 1 on the bottom? Nope. You have a 3x plus 2 up top. Is there a 3x plus 2 on the bottom? No. So there is nothing that's on the top that's on the bottom, and vice versa. There is nothing on the bottom that's on the top. So this fraction simplified is literally the factored form of both the numerator and the denominator. There is nothing that's the same on both. So there's nothing that you can simplify or cancel out from this. All right. So for this example for A, you are multiplying the two fractions together that have expressions in both your numerator and denominator that you're going to have to factor. For example A, you're given 2x squared plus x minus 6 over x squared plus 4x minus 5 times x cubed minus 3x squared plus 2x over 4x squared minus 6x. Now, with these, when you're multiplying, dividing, even adding and subtracting, you want to factor first. Anything and everything within those fractions, you are going to factor completely. From there, if you can simplify, I would simplify, and then you multiply, divide, whatever you want to, whatever it's telling you to do. So the first numerator that you have there, you have an a that's something other than 1, so you're going to multiply your a and your c. 2 times negative 6 is negative 12. Your factors of negative 12 that add up to be positive 1 are negative 3 and positive 4. So that gets rewritten as 2x squared minus 3x plus 4x minus 6. We factor that by grouping. We're going to factor out an x from this, a 2 from that. So that's going to give us x plus 2 times 2x minus 3.
Can you put that text above in the white space, please?
No, because I already wrote it down and I'm recording this, so I can't move anything around. In your completed notes, you'll be able to see it all. It just says 2 times negative 6 is equal to negative 12, and then the factors of the negative 12 are 4 and negative 3. That add up to be positive 1. So from here, you're going to factor the denominator of that first fraction as well. That negative 5 has factors of negative 1 and 5. That add up to be 4. So it's going to be x minus 1 and x plus 5. The second fraction numerator, you have a greatest common factor of x, so that'll factor out first to give you x times x squared minus 3x plus 2. Your factors of positive 2 that add up to be negative 1 negative 3 are negative 1 and negative 2. So that factors to be x times x minus 1 times x minus 2. Then in your denominator of that second fraction, your greatest common factor is 2x. So that's going to give you 2x times 2x minus 3. You are going to ask yourself if there is anything within the same parentheses or same set of same fraction, top and bottom, or diagonally from one another that you can simplify. Start with the x plus 2. There is not an x plus 2 within that same fraction or diagonal from it, so you can't factor or you can't simplify that. The 2x minus 3, you have a 2x minus 3 diagonally from that, so those will cancel out. You have an x minus 1 in the bottom of the first fraction and the top of the second fraction. Those simplify. You also have an x on the top and the bottom of the second fraction, so those simplify. So this is just going to give you x plus 2 over x plus 5 times x minus 2 over 2. Since you are multiplying these, you will multiply straight across. And that'll just give you x plus 2 times x minus 2 over 2 times x plus 5. For example B, you have x squared minus x minus 12 over x squared plus 2x plus 2 times x squared plus 8x plus 12 over x squared plus 2x minus 15. From the numerator of the first fraction, your factors of negative 12 that add up to be negative 1 are negative 4, positive 3. So that factor is to be x minus 4 times x plus 3. The denominator of that first fraction, there are no factors of 2 that add up to be positive 2. So that's going to stay the x squared plus 2x plus 2. From the top of the second fraction, your factors of positive 12 that add up to be positive 8 are 2 and 6. So that factors to be x plus 2 times x plus 6. From the bottom of the second fraction, your factors of negative 15 that add up to be positive 2 are negative 3 and positive 5. So that's going to give you x minus 3 times x plus 5. From here, there is nothing that is diagonal from each other that can simplify or on top of one another that can simplify. So you are just going to multiply this straight across, keep it in factored form. So that's going to give you x minus 4 times x plus 3 times x plus 2 times x plus 6 all over x minus 3 times x plus 5 times x squared plus 2x plus 2. The next part that we're going to look at is dividing these rational expressions. When you divide, you're going to do the same thing to start that you did when you were multiplying. You are going to factor every part within the fraction. Then you will keep change flip, simplify, and multiply. For example, A, you're given 2x squared minus 5x minus 3 over 2x squared plus 9x plus 4 divided by 3x squared plus 2x minus 1 over x squared plus 10x plus 24. For the top of the first fraction, you have a 2 and a negative 3 that multiply. That gives you negative 6. Your factors of negative 6 that add up to be negative 5 are 1 and negative 6. So that's 2x squared plus x minus 6x minus 3. You factor this by grouping. Factor out an x from the first. Factor out a negative 3 from the second. That gives you x minus 3 times 2x plus 1. The bottom of the first fraction, you have 2 and 4 that's going to multiply. That gives you 8. Your factors of 8 that add up to be 9 are 1 and 8. So that's 2x squared plus x plus 8x plus 4. Again, factor this by grouping. Factor out an x from the first. Factor out a 4 from the second. That's x plus 4 times 2x plus 1. On top of the second fraction, you have 3x squared plus 2x minus 1. The 3 times negative 1 gives you negative 3. Your factors of negative 3 that add up to be positive 2 are 3 and negative 1. So that's 3x squared plus plus 3x. I was right. Minus x minus 1. So we factor this by grouping. Factor out a 3x from the first. Factor in a negative 1 out from the second. That gives you 3x minus 1 times x plus 1. Then on the bottom of your second fraction, your factors of 24 that add up to be 10 are 6 and 4. So that's x plus 4 times x plus 6. because we are dividing, we are going to keep, change, and flip. So that's going to stay x minus 3 times 2x plus 1 over x plus 4 times 2x plus 1. Change to multiplication, then flip the second fraction to be x plus 4 times x plus 6 over 3x minus 1 times x plus 1. From here, simplify. Within the first fraction, you have a 2x plus 1 on the top and the bottom of that fraction. Then you have a x plus 4 on the bottom of the first fraction and the top of the second fraction, so those simplify as well. This is going to leave you with x minus 3 over 1 times x plus 6 over 3x minus 1 times x plus 1. You cannot simplify this any further, so multiply straight across to give yourself x minus 3 times x plus 6 over 3x minus 1 times x plus 1. For example B, we have x squared minus 4x minus 21 over x squared minus 7x minus 18 divided by x squared plus 9x plus 18 over x squared minus 10x plus 9. For the top of the first fraction, your factors of negative 21 that add up to be negative 4 are 3 and negative 7. So that factors to be x plus 3 times x minus 7. In the bottom, your factors of negative 18 that add up to be negative 7 are x plus 2 and x minus 9. Then the top of the second fraction, your factors of 18 that add up to be 9 are going to be 3 and 6. So that's x plus 3 times x plus 6. And the bottom of the second fraction, your factors of 9 that add up to be negative 10 are going to give you x minus 1 times x minus 9. Now that we're completely factored, we're going to keep, change, and flip. So that's going to give us x plus 3 times x minus 7 over x plus 2 times x minus 9 times x minus 1 times x minus 9 over x plus 3 times x plus 6. You can simplify your x plus 3's as well as your x minus 9's. So this just gives you x minus 7 over x plus 2 times x minus 1 over x plus 6. So you multiply this straight across, and that leaves you with x minus 7 times x minus 1. And this is over x plus 2 times x plus 6. For our next set of examples, we're just performing the indicated operation. For example A, you're given 3x squared plus x minus 4 over x squared minus 2x minus 3 times x squared minus 1 over 2x squared plus 5x plus 3. On the top of the first fraction, you have an A that's something other than 1. So we're going to multiply 3 and negative 4. That gives us negative 12. Your factors of negative 12 that add up to be positive 1 are 4 and negative 3. So we're going to rewrite this as 3x squared plus 3x, minus 3x, not plus 3x, minus 3x plus 4x minus 4. You factor this by grouping. Factor out a 3x and a 4, and that'll give you 3x plus 4 times x minus 1. In the bottom of that first fraction, your factors of negative 3 that add up to be negative 2 are negative 3 and positive 1. So that's x minus 3 times x plus 1. Your second fraction, that x squared minus 1 is a difference of squares. So that's just x minus 1 times x plus 1. The bottom of that second fraction, you have an A that's something other than 1. So multiply your 2 and your 3. That gives you 6. Your factors of 6 that add up to be 5 are 2 and 3. So that's 2x squared plus 2x plus 3x plus 3. Factor by grouping. Factor out a 2x and a 3. So that's 2x plus 3 times x plus 1. From here, simplify before you multiply. The 3x plus 4, you don't have another one of those. The x minus 1 diagonally, you don't have another one of those. X minus 3 diagonally, no. X plus 1, yes. From here, you still are left with the x minus 1, the 2x plus 3, and the x plus 1. Diagonally, those don't simplify. So look at within the same fraction. You don't have anything within the same fraction that simplifies either. So multiply with what you have left over straight across. That's going to give you 3x plus 4 times x minus 1 times x minus 1 over x minus 3 times 2x plus 3 times x plus 1. For our next example, we have 2x squared plus 15x plus 27 over 3x squared minus 19x minus 14 divided by 2x squared plus 17x plus 36 over 2x squared minus 15x plus 7. From the numerator of the first fraction, we are going to multiply the 2 and the 27. That gives us 54. We want the factors of 54 that add up to be 15. That's 9 and 6. So this is going to give us 2x squared plus 6x plus 9x plus 27. We group these, factor out a 2x from the first, factor out a 9 from the second. That's going to give us 2x plus 9 times x plus 3. In the bottom of that first fraction, you have a 3 and a negative 14 that you're multiplying together. The 3 times 4 is 12. We carry the 1, so 3 times 1 plus 1 gives us a negative 42. From here, we want the factors of negative 42 that add up to be negative 19. You know 3 and 14, if they're different, they're not going to give you what you need. If you have 2 and 21 here, and that 2 is positive, that 21 is negative, that would give you the negative 19. So this is going to be 3x squared minus 21x plus 2x minus 14. We factor by grouping there. We're going to factor out a 3x and a 2. And we're going to have x minus 7 left. The top of the second fraction, you have 2x squared plus 17x plus 36. So you're going to multiply 2 and 36. That gives you 72. You want the factors of 72 that add up to be 17. So 72 is 6 and 12. That doesn't work. But 9 and 8 do. Okay, so this is 9 and 8. So we're going to rewrite this as 2x squared plus 8x plus 9x plus 36. So we're going to group these, factor out a 2x, factor out a 9. That's going to give us 2x plus 9 times x plus 4. Bottom of the second fraction. You have 2x squared minus 15x plus 7. 2 times 7 is 14. Your factors of 14 that adds to be negative 15 or negative 1 and negative 14. So that's going to be rewritten as 2x squared minus x minus 14x plus 7. Factor by grouping. This is an x. This is a negative 7. So that's x minus 7 times 2x minus 1. So from here, since we are dividing, we are going to change to multiplication, flip the second fraction. That's going to give us 2x plus 9 times x plus 3 over 3x plus 2 times x minus 7 times x minus 7 times 2x minus 1 over 2x plus 9 times x plus 4. You have a 2x plus 9 that's diagonal from one another. You also have an x minus 7 that's diagonal from one another. You do not have anything else that'll simplify with each other, so that's just going to give you x plus 3 times 2x minus 1 over 3x plus 2 times x plus 4. So if we look at example 7, you're just performing the operations and simplifying. For this one, you're adding and subtracting. So what I suggest for you to do is to factor your denominators. When you're adding and subtracting, you don't need to factor your numerators, just factor your denominators. So that denominator of the third fraction here, that x squared minus 1, does factor to be x minus 1 times x plus 1. So we are going to rewrite this as 3 over x minus 1 minus 2 over x plus x plus 3 over x minus 1 times x plus 1. So looking at these three fractions all together, your least common denominator is x times x minus 1 times x plus 1. The first fraction does not have the x or the x plus 1 in the denominator. So we would multiply that 3 by x as well as x plus 1. The second fraction, your denominator is just the x. It's missing the x minus 1 and the x plus 1. So we're going to multiply that by x minus 1 and x plus 1. The numerator of the third fraction, you are going to multiply just by x because that denominator is missing just the x from the least common denominator. So I'm going to rewrite this to give myself 3 times x plus 1 minus 2 times x minus 1 times x plus 1 plus x times x plus 3 all over our least common denominator of x times x minus 1 times x plus 1. The 3 times x is going to give you 3x. You're going to multiply that still by x plus 1. That negative 2 is going to multiply by x squared minus 1 because the x minus 1 times x plus 1 is a difference of squares. You can also distribute that x into the x plus 3 to give you x squared plus 3x. And again, this is all going to stay over x times x minus 1 times x plus 1. From here, distribute the 3x in, distribute the negative 2 in. That's going to give us 3x squared plus 3x minus 2x squared plus 2 plus x squared plus 3x all over x times x minus 1 times x plus 1. From here, simplify your numerator, combine like terms. Bless you. Combine like terms in your numerator. So you have 3x squared minus 2x squared, which is x squared, plus x squared gives you 2x squared. Then you have 3x and 3x, which is 6x. And lastly, the positive 2 drops down. And this is all over x times x minus 1 times x plus 1. You need to factor your numerator from here. You have a greatest common factor between all three of these terms, which is 2. So that factors to be 2 times x squared plus 3x plus 1 all over x times x minus 1 times x plus 1. Check to see if you can factor the trinomial now in that numerator. it's just x squared plus 3x plus 1. You do not have factors of positive 1 that add up to be 3, so you cannot factor that. That is your answer. If you factored out an x with that 2, you would be able to simplify that. However, you didn't, which is why you're not simplifying anything else from here. So for your complex fractions, like it just said, fraction within a fraction, you need to realize that fractions represent division. You can rewrite all of these as division problems. So if you look at like the first example here, that 1 over x squared plus 1 is the same exact thing as saying 1 over x divided by x squared plus 1. For the one on the bottom, that 1 over x squared plus 1, it's the same thing as saying 1 over x divided by 1 over x squared plus 1. Remember, when we're dividing, we keep, change, flip. So with both of these, you would keep the first fraction, change to multiplication, then flip the second fraction. There is no factoring with any of these before you multiply them or divide them, so you wouldn't have to do that step. If we look at that bottom one, which is written again on this page, we said that that was 1 over x divided by 1 over x squared plus 1. Again, we're going to keep, change to multiplication, then flip the second. So that means we're going to have 1 over x times x squared plus 1 over 1. We multiply this straight across. So that's just x squared plus 1 over x. For our last example, we have 2 over x minus 3 over 1 minus 1 over x minus 1. So this one's a little bit more complicated, but again, we are going to rewrite it as 2 over x minus 3 or 3 over 1 divided by 1 or 1 over 1 minus 1 over x minus 1. So from here, you're going to follow your order of operations. You are going to do what's in the parentheses first. So on that first set of parentheses, you have 2 over x and 3 over 1. Your least common denominator is x. The only fraction that does not have the x in the denominator is the second one, so you multiply the 3 by x. So that's going to give you 2 minus 3x all over x. For the second set of parentheses, your least common denominator is x minus 1. So we're going to multiply that first fraction's numerator by x minus 1. And that's going to give us x minus 1 over x minus 1. Combine your like terms in that second set of parentheses or that second fraction. The negative 1 minus 1 gives us negative 2. So that's 2 minus 3x over x divided by x minus 2 over x minus 1. We're going to keep, change, and flip from here. So that's going to give us 2 minus 3x over x times x minus 1 over x minus 2. I'm going to put parentheses around anything that I have that is more than just one term in the numerator or the denominator. So that way when I multiply straight across, I keep them in parentheses. So this is going to give us 2 minus 3x times x minus 1 over x times x minus 2.